Okay, so now we're going to move on to something called the unit circle. So let's go ahead. Say we have, this is the origin in the plane. I messed it up. Right there is the origin. So say that's the origin in the plane, okay? XY plane. This is your X, this is your Y, okay? Let's create a circle around that origin. Okay? It's not the best circle, but it has a radius of 1, meaning this point right here is going to be 0, 1. Or other way around. 1, 0. So this point up here would be 0, 1. This point down here would be -1, 0. This point right here would then be 0, -1. Okay? Got that? So now, what are some other properties of the circle? Well, if I go ahead and create like a distance right here, this hypotenuse, this distance from the origin is always going to be 1, right? But look at that. It's a right angle triangle with a hypotenuse 1 if I make it 1. This right here is the x, right? That is the distance from the origin. That's x. That's your x coordinate, right? And this right here, right? That's going to be your y. That's going to be your y coordinate. This right here is going to be the point x, y, right? Okay, what are the values of this? Well, if I say it's this thing right here is at an angle theta, like we did last time, right? We now have a right angle triangle with an angle theta right there. And now, with the hypotenuse 1, okay? This right here, this distance is going to be your x coordinate. This right here is going to be your y coordinate, okay? So what's the sign of your theta going to be? Well, it's going to be your y over your hypotenuse, your opposite, which is y, over your hypotenuse, which is 1. Y over 1. Okay? Which is going to be y. Okay? So the cosine of your theta is going to be your adjacent x over 1. X over 1. Which is just going to be x. Okay? Well, look at that. We have cosine theta is x, meaning x is cosine of theta. And we have y, sine of theta is equal to y, which means y is the sine of theta. Meaning, this point right here, plugging in for x and y, is just going to be the cosine of theta, and then sine theta, right? That's going to be your Cartesian coordinates. That's what we call it, where you have an x and a y coordinates, okay? So now let's go ahead and look at some other things on this same circle. So I have my circle. Right now I'm not going to look at it in the plane. It has a radius 1. That means the circumference is 2 pi. Okay? So let's divide it up into little sections, okay? Each of these are 1/4 of the circle, right? 1/4 of the circumference away, right? So this right here is 1/4 of the circumference away from this point along the circle, right? That means that its distance from this point along the circle, that little arc, right? That's going to be pi on 2, right? 2 pi on 4 is the same thing as pi on 2. this distance along here, right, that distance is going to be 1/2 of the circumference, which is just going to be pi. This right here, this distance along there, it's going to be 3/4 of the distance. 3/4 times 2 pi. 3/4 times 2 pi. 3/4 of 2 pi, which is the entire length around, is going to be, well, that's going to be 2, that's going to be 1, it's going to be 3 pi on 2. 3 pi on 2. This right here is going to be 2 pi then, right? But it could also be 0. You didn't move at all, okay? What about if I divide this section in half, like that? So 1/2 of pi on 2 is pi on 4. Let's say I divide it into thirds with those two. So this distance right here, that distance is going to be a third of this, or pi on 6. This right here is going to be 2/3, or pi on 3, right? It's all based on the arc from this starting point to that point, right? If you go all the way around the circle, it would be 2 pi. If you stay there, you've basically traveled 0. Here, you've traveled pi on 6 as a distance. Here, you've traveled along the circle pi on 4. Here, you've traveled pi on 3 along the circle. Here, you've traveled pi on 2. Right here, divide that in half. Now we have a half, and another half of pi on 2, so it's going to be 3 pi on 4, right? This right here turns out to be 5 pi on 6, right? Because it's going to be your 6th, then a 6th, then a 6th, then a 6th, then a 6th. You get the idea. You can do that 5 times to get to that point. Right here, it's going to be 2 pi on 3, right? This right here is pi on 3. There's going to be 2 pi on 3. Then you can go all the way around the circle, marking out how much arc it has. Now each of these corresponds with an angle, right? This right here would be 30 degrees because it's 1/3 of this, which is 90 degrees. So 1/3 of 90 degrees is 30 degrees. This is 45 degrees because it's half of this, which is 90 degrees. This is going to be 60 degrees, 2/3 of 90 degrees. Then there's 90 degrees. Then there's 120 degrees. And then it keeps going all the way around the circle, which with degrees. Right, this distance right here is going to be 180 degrees, which corresponds with a distance of pi. So 180 degrees corresponds with the distance of pi. It's a ratio of pi to 180 degrees. Well, what if instead of having each of them separated, like angles and arc and distances along the circle, what if they were all just one thing? What if instead of having angles in degrees, we had them in how much arc they had with a radius of 1 on a circle? So what radius, corresponding with the radius of 1, how much arc does it take up, that degree, right? Understand? So radius, so how about we call these radians? Okay? So for every pi radians, rad, over 180, there are 180 degrees. This is the ratio of radians to degrees. And radians are very important, and we'll see that in a future video.